Hello, welcome back to GIT. My name is Okunema George. I'm a data scientist. I will be your instructor for today. So today we are going to look at a very important concept in natural language processing (NLP). In our last tutorial, we had a very nice section which I taught you the basics of natural language processing using SpaCy as a library. So today we are going to look at what we call text similarity analysis. Now, text similarity analysis is widely used in recommendation systems, plagiarism detection, and search engine. Now, most of us, if you want to look at content written by AI, you will use what we call plagiarism detection. It detects if this text was written by AI. So that is exactly what we are going to build in this tutorial today. So if today is your first time of seeing this video, my name is George. I teach data science and machine learning engineer, and also if you're a returning subscriber, I want to say thank you for coming, and I believe you had a very nice time in our last tutorial and looking forward to have better videos prepared just for you. So without any further ado, let's dive into our computer and start the process. All right, so as usual, I'll go to my menu and my command prompt. Okay, I'm going to first of all go to my desktop. All right, so I'm going to make a directory, a folder known as text underscore summarizer. All right, so I'm going to navigate to that text summarizer, text underscore summarizer. All right, very good. So I'm going now to open this with VS Code. All right, so just wait while it's loading. I'm opening this inside VS Code. So like I said, text summarizer is used for text similarity analysis. It is a tool that is used to summarize text. You know, you can have two documents, or you can have two documents. You want to compare the similarity between each of those documents. You want to find out if certain words that are found in this document are also found in the second document. So this is what we do while using text similarity. Sorry, I spelled summarizer. It's not summarizer. We are looking at text similarity. Text or documents or words that are similar in different documents. That's what we are going to look at for today. So let me go ahead and create my folder. Okay, I will say text. I want to open this with Jupyter Notebook. All right, so the first thing we need to do is let me use a markdown. We are going to first of all import our library. All right, so the first library we are going to import this in this tutorial is, as usual, is our SpaCy library. Say import SpaCy. All right, so you are going to click on enter. This is the first time I'm opening this VS Code this morning, so it's going to load. So just give it some time. So we are going to look at text similarity. All right, so the next thing we are going to do now is we are going to load our model, load our pipeline or model. Okay, this is how we are going to load our model. We're going to say NLP equals to SpaCy dot load. We are going to load English model. All right, you see en underscore core underscore web underscore sm. All right, okay, so we have been able to import our pipeline or a model. So the next thing we're going to do now is to go ahead and have our text write through text. All right, so the first text, we're going to say the variable known as text1 equals to, we're going to say artificial intelligence is the future. Now text2, we are going to say machine learning will shape the future of technology. Let's go ahead and run this. All right, so now we are going to do what we call text processing. All right, we are going to do something known as text processing. All right, so remember I told us in our last tutorial that if you go ahead and print this text, it's going to give us very lengthy kind of text, kind of, understand. But if we are going to shape it into a document is kind of, it summarizes, it compresses it by word, while in text it's giving us alphabetical by alphabet, it counts by alphabet. But in document it counts or it groups them by what? By tokens. Tokens are words, or is a process of splitting a sentence or a document or a text into what? Smaller units. So that unit is called token. So in document, we are going to further split this text into what we call tokens. All right, so we are going to say doc1, as we have two documents, we also have two documents, equals to, we say NLP open and close bracket, and we call our text1. All right, so we do same for document 2 equals to NLP, we are going to call our text2. All right, we'll go ahead and print this. So let me show you a quick example between text1 and document 1. In text1, if I go ahead and say for token in text1, all right, print, or would have token. If I go ahead and print this, you can see that it's giving us very lengthy. All right, it's giving us, right, it's counting based on the number of words, alphabet rather, in that text. Okay, but if I should change this to document 1 to doc1, and I go ahead and print the same thing, so it's giving us as what? Artificial intelligence is grouping it by word. So this is the difference between text and document, and that is how we always have to convert our text into documents, so we can compress it to give us tokens by words or by phrases. I hope you understand that. In our last tutorial, I was able to emphasize based on this. All right, so let's move on. All right, so basically what we are going to do now is we are going to look at the similarity between document 1 and document 2. All right, it's going to give us as a vector. Okay, it's going to give us by percentage. All right, so let's go ahead and do this. We say similarity, I'm going to give it similarity equals to, all right, so equals to document 1 dot similarity, you open and say document what? Document 2. All right, so we are going ahead and run this now. All right, so this is what it's giving us, but let's go ahead and print this similarity. All right, let's go ahead and say print. We are going to use f string. All right, we want to write something. We say it text similarity. All right, you do open and close curly braces. All right, we now call this our variable. This variable here, we call it here. Now we want it to be in 2 decimal points, 8.2 f. All right, if we go ahead and go ahead, so we now have 0.45% similarity. So this is what I said in the beginning, that in this you can use this and build a model that looked at plagiarism detection, to detect words that were written or copywriting. Now, as a lecturer or as a teacher, maybe you gave an assignment, you want to check if students copied from each other, or you want to look at the originality of the words, okay, or of the document or of the project. Now you can build something like this and compare the two documents together. Now you are comparing to see which one, if they have 100% or a greater percentage of similarity. Now, in other words, if we look at our text 1, it said artificial intelligence is the future. And you look at the text 2, machine learning will shape the future of technology. So the similarity between these two is the future that's inclusive here. That's why we have a very low percentage at 0.45. Now let's go ahead and do another example. Let me just say doc 3 equals to let's say NLP, let's say Apple. All right, now let's do document 4 equals to NLP, and you say mango, and you print. So let's go ahead and copy this same I don't want to type it again. Let's just go ahead and now look at similarity between document 3 and document 4, and let's go ahead and also copy this. All right, copy this and paste it here. All right, and go ahead and print it. So if you look at this, it's giving us as a rate of 0.46%. all right, so there is the similarity between apple and mango is 0.46%. If we change this mango to apple, all right, now you go ahead and run this, and you run this, it's giving us as 100% similarity. It therefore means that they are the same thing. Now let's do something very important. Apple, let's say orange rather, and go ahead and run it, we are having it at 0.43%. so the similarity between these two words, they are 0.43. and if we come to our document here, document 1 and document 2, we have it at the rate of 0.45% similarity. Now if you are detecting, you can see that the margin is very low, so you can allow this to fly, because it's possible that in the course of writing the project, they both use the same words that are similar. That doesn't mean that they copied from each other. But when you have from 50, 70, 80 to 100% similarity, there, that word was copied, or those words were copied from artificial intelligence, let's say ChatGPT. So this is how you can use, as a lecturer or as a teacher, to how you can use machine learning or natural language processing, NLP, to detect similarity in words in two or more documents. I hope you are finding value in this tutorial, in this video. Please, if you are doing that, please just smash that like button so that YouTube algorithm can push this video to people like you that are interested in NLP analysis. So, and also, if you have not yet subscribed to my channel, please do well to hit and smash that subscribe button. In our next tutorial, we are going to look at other projects. We are going to be building different projects on this channel based on natural language processing. Please do well to subscribe so that you'll be the first person to see my new videos once I upload. And by the special grace of God, I'll be making uploads every week. So expect new videos and new projects by next, because I'll be dropping on a weekly basis. My name is George. Don't forget to subscribe, also to push this YouTube algorithm by liking this video, and also put your comment in the comment section. Let me know your mind. If you have any question, please do well to as well put it on the comment section. I will ensure that I make a video to explain better than this. So in our next tutorial, we are going to build a different project in NLP. So thank you, and see you in our next tutorial.